Hi everyone, welcome to Max Academy. In this video, we will continue with the Matrices chapter, which is the third chapter from your 12th standard CBSE mathematics. We will continue with exercise 3.3 in page number 88 of your textbook. The first question is, find the transpose of each of the following matrices. So first question, first part, A is the matrix which is 5, 1 by 2 minus 1. We have to find the transpose of this matrix. Excuse me. So transposes, we will we'll interchange the rows and columns of A. So we have one column, we will write that as row. So 5, 1 by 2 minus 1. So this is the transpose of the given matrix A, right? The second question is on the first problem. Second subdivision is the matrix is 1, 1 minus 1, 1 minus 1, 2, 3. Suppose if we call this as B. So B matrix, we have to find the transpose of this matrix. So what is the transpose of this matrix? B transpose, we can say BT or B dash. Both can be used for transpose. So B transpose is, you have to write rows as column or column as row. So 1, 2, minus 1, 3. So this is the transpose of this matrix. Fine. The next one is the third question. So suppose if we take that as C equal to minus 1, 5, 6, minus 1, 5, 6, root 3, 5, 6, 2, 3, minus 1. 2, 3, minus 1. Now we have to find the transpose of this. So again, so C transpose is C dash. You have to write the rows as column, columns as rows. So it will become minus 1, root 3, then 2, then 5, 5, 3, 5, 5, 3, then 6, 6 minus 1, 6, 6 minus 1. So this is the transpose of the given matrix. Fine. So all of you can copy this, pause the video and take the notes. I'll go to the second question. So second problem. Second problem is A is given, B is given. So A matrix is minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. Then B matrix is minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. So the two matrices are given, A and B. We have to verify that. The first part is A plus B, the whole transpose equal to A transpose plus B transpose. We have to verify this. The second verification, A minus B whole transpose is equal to A minus B, the whole transpose is equal to A transpose minus B transpose. So we have to verify both these. So let's take the first part, right, solution. So let's find the LHS. So for the first one, we'll take A plus B. Let's try to find A plus B. What is A plus B matrix? We have to add A matrix. Minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. With plus B matrix is minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. So let's add them. What do we get? If we add them, so minus 1 minus 4 is minus 5, 2 plus 1 is 3, 3 minus 5 is minus 2, then 5 plus 1 is 6, 7 plus 2 is 9, 9 plus 0 is 9, minus 2 plus 1 is minus 1, 1 plus 3 is 4, 1 plus 1 is 2. So this is your A plus B matrix. Fine. Now we should find A plus B whole transpose. So what is A plus B whole transpose? That will be, you have to write this as rows into column and column as rows. So minus 3, minus 5, 6, minus 1, 3, 9, 4, minus 2, 9, 2. So this is the A plus B whole transpose. Now we should find A transpose and B transpose and then we should add them. So A transpose plus B transpose will be equal to, let's write the transpose of A. Transpose of A is minus 1, 5 minus 2, 271, 391. So I have interchanged the rows and columns, right? So this is A, I have written A transpose, then P transpose is plus B transpose. B transpose is minus 411, 123, minus 501. Now let's add both of them. So if we add both, that is equal to, what do we get? If we add minus 1 minus 4 is minus 5, and 5 plus 1 is 6, minus 2 plus 1 is minus 1, then 2 plus 1 is 3, 9, 1 plus 3 is 4, 3 plus minus 5 is minus 2, 9 plus 0 is 9, 1 plus 1 is 2. Fine. Now if you see this A plus B whole transpose is this matrix, A transpose plus B transpose is this matrix, and both are same. Both the matrices match. Therefore we can say A plus B the whole transpose equal to A transpose plus B transpose. So we have verified the first part. So this is over. Now we should check the second part. So second part, let me erase this. So second part we have to prove is A minus B whole transpose. So let's find what is A minus B. So A minus B will be, A is minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1, minus B. B matrix is minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. So let's find A minus B. A minus B. Right? So minus 1 minus of minus 4 is plus 4. So 1 plus 4 is minus 1 plus 4 is minus plus 3. Then 2 minus 1 is 1. 3 minus of minus 5 is 8. Then 5 minus 1 is 4. 7 minus 2 is 5. 9 minus 0 is 9. Minus 2 minus 1 is minus 3. 1 minus 3 is minus 2. 1 minus 1 is 0. So this is your A minus B. Now let's find A minus B the transpose. We have to find A minus B the transpose, and that is equal to, we have to take the transpose of this matrix. So what is the transpose of this? 3, 4, minus 3, 1, 5, minus 2, 8, 9, 0. So this is A minus B transpose. So this is your A minus B, and to that we have taken the transpose. Clear? So this is A minus B the transpose. Now let's find what is A transpose minus B transpose. So A transpose minus B transpose is equal to, let's write A transpose first. A transpose is this one, minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1. So A transpose minus B transpose is minus 4, 1, 1, 1, 2, 3. I'm just reusing this. Minus 5, 0, 1. Right? Now let's find what is A minus B. So A minus B becomes, so this minus is, so minus 1 minus minus 4 is again 3. Fine. Then 5 minus 1 is 4. Minus 2 minus 1 is minus 3. Then 2 minus 1 is 1. 7 minus 2 is 5. 1 minus 3 is minus 2. 3 minus of minus 5 is 8. 9 minus 0 is 9. 1 minus 1 is 0. So we got the same matrix. So A transpose minus B transpose. A transpose minus B transpose matrix is also matching with A minus B the whole transpose. These two are matching. So therefore we can say A minus B the whole transpose is equal to A transpose minus B transpose. So we have verified the second part also. Clear? Fine. So that completes the second problem. Fine. So you can do the third problem as do it yourself or homework. So third problem is similar to that. Only thing is, in third problem is do it yourself or homework. You can try by yourself. It's similar to the second problem. The only difference is in the third problem they have given A transpose. They have given A transpose and B matrix. So you have to take You have to first find A from that. So from A transpose, if you take whole transpose, you will get A. So A transpose is given. From that you have to find A, and then you know A and B, then you can verify the result. So third can be done. I will do the fourth one. Fourth question in the exercise. Let me erase these things. Okay, now what we have is the fourth problem, which is A transpose is given. A transpose is given as minus 2, 3, 1, 2. That is A transpose. Then B matrix is given as minus 1, 0, 1, 2. Now we should find what is A plus, find A plus 2B the whole transpose. A plus 2B the whole transpose. Fine. So now let's go and find what is A plus 2B first. So solution is A plus 2B. A plus 2B equal to A. A is, we have tried to see A transpose is given. You have to first to, so in the A don't substitute this. You have to take the transpose of this. A is what? Transpose of A transpose will give you A. So this will be minus 2, 1, 3, 2. I am writing this as rows and columns. See, when A transpose is given, what is your A? Your A becomes minus 2, 1, 3, 2. This becomes your A. To take the transpose of this, you get A. So A is not given, A transpose is given. So you have to be careful with the question. But for B, only B is given, not B transpose. Only B is given. So now let's substitute that. I have substituted A plus 2 times B. You can substitute minus 1, 0, 1, 2. Then so you get minus 2, 1, 3, 2 plus 2 times minus 1 is minus 2, 0, 2 ones are 2. Each element has to be multiplied by 2. Then you have to add them. Minus 2 is minus 4. 1 plus 0 is 0. Sorry, 1. Then 3 plus 2 is 5. 2 plus 4 is 6. This is your A plus 2B. So we have found A plus 2B. But what we have to find? We have to find A plus 2B the whole transpose. So A plus 2B the whole transpose is transpose of this. So you get minus 4, 5, 1, 6. So this is your answer. That is your answer, right? So copy this and I'll go to the fifth question. Fifth question is important. It's easy though. So fifth question is, what is given? In fifth question, for the matrices A and B, verify AB transpose, AB the whole transpose equal to B transpose A transpose. So A matrix is given. I am doing the first one. So A matrix is 1, minus 4, 3. And B matrix is minus 1, 2, 1. Right? Now, there is no comma, sorry. Minus 1, 2, 1. Now, we should verify this, which is one of the properties of transpose. AB whole transpose, we should show it as B transpose into A transpose. But verify this. So let's find the left hand side, which means we'll find AB whole transpose. So first we'll find AB. Solution is AB. AB is A minus 1 minus 4 1 minus 4 3 A into B. B is minus 1 2 1. Right? If you multiply A into B, you get 1 into minus 1. So again, here it is, order is 3 cross 1 and this is 1 cross 3 matrix. So number of columns equal to number of rows, so we can multiply. So first row with the first column, 1 into minus 1, then 1 into 2 is 2, 1 into 1 is 1, minus 4 into minus 1 is 4, minus 4 into 2 is minus 8, minus 4 into 1 is minus 4. 3 minus 3 into minus 1 is minus 3, 2 3s are 6, 3 1s are 3. So this is your AB. This is your AB matrix. Now let's try to find what is AB transpose. So AB whole transpose. You have to take the transpose of this matrix. So transpose of this will be minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4, 3. So that is your transpose. Now we should find B transpose into A transpose. Now what is B transpose? Into A transpose, that is equal to B transpose. So transpose of this is minus 1, 2, 1. We have to take the transpose of this. Then transpose of this will be a row matrix, which is 1, minus 4 and 3. Now let's multiply. What do we get? So 1 into 1, minus 1 into 1 is minus 1, minus 1 into minus 4 is 4, 1 into minus 3 is minus 3, 2 times 1 is 2, minus 8, 2 times 3 is 6, 1 times 1 is 1, 4, 3. That is your B transpose A transpose. So your B transpose A transpose is this, and AB whole transpose of this, then both the matrices match. Right? Both the matrices match. So this matrix is same as this matrix. Therefore, we can say AB whole transpose equal to B transpose A transpose. So I can write the conclusion here. Therefore, we can say AB whole transpose equal to B transpose A transpose. So that is verified. So we have verified this. Fine. So on the fifth problem, second part, you can do it as homework, which is same as this. So fifth problem, second part is do it yourself or homework, whatever, whichever way you want to call it. So you will be able to do. Similarly, you have to verify this. The same result. The two other matrices A and B are given. You have to verify this. Fine. Now let's go to the sixth problem, first sub problem. So sixth one, first sub problem. So A matrix is given. A is cos alpha, sin alpha, minus sin alpha, cos alpha. Now what we should prove is verify that A transpose A equal to I. You have to show that when you multiply A transpose with A, you should show that it is equal to I, and I is what? I is a identity matrix of order 2. So I means what? I means it is this 1 0 0 1. The A's order is 2 cross 2 means I's order is also 2 cross 2. So it's a identity matrix 1 0 0 1. We have to show that if you multiply A transpose with A, I should get I. So solution. Let's do A transpose into A. What is A transpose? Take the transpose of this. That will be cos alpha minus sin alpha, cos alpha. That multiplied with A matrix, that is cos alpha, sin alpha, minus sin alpha, cos alpha. So the A transpose of this, then into A matrix. Now what do we get if you multiply this? First row with first column. Cos alpha into cos alpha is cos square alpha, plus minus into minus plus, sin alpha into sin alpha is sin square alpha. This into this. Then this into this. So this into this plus this into this. So it's cos alpha sin alpha, sin alpha, minus sin alpha cos alpha. This into this. Again sin alpha into cos alpha plus cos alpha into minus sin alpha. So sin alpha cos alpha minus sin alpha cos alpha. And again this one is sin alpha into sin alpha is sin square alpha, then plus cos alpha into cos alpha is cos square alpha. So cos square alpha plus sin square alpha is 1, which is our trigonometric entity. So here these two will get cancelled because this is plus, this is minus. Here also they will get cancelled. So you'll get 0, 0, and sin square alpha plus cos square alpha is 1, which is equal to I. So we have proved A transpose into A equal to the identity matrix of order 2. So we have verified this. A transpose into A equal to I. Fine. So sixth question, second part is similar problem. So you can do it yourself or homework, whatever. Do it by yourself do it yourself or homework. Fine. So let's go to the 7th problem. So all of you can take the notes. I will go to the 7th one here. So 7th problem is, it says we have to verify, show that the matrix A is a symmetric. So 7th first part. So A matrix is given, which is 1 minus 1 5 minus 1 2 1 5 1 3. We have to show that it is symmetric. What do we have to show? Show that A is symmetric matrix. And show that A is symmetric matrix. And to show A is a symmetric matrix, we have to find the A transpose, and we should show that A transpose is equal to A. If A transpose is equal to A, then A becomes a symmetric matrix. So solution is, let's find A transpose. What is A transpose? Transpose of this. So 1 minus 1 5 minus 1 2 1 5 1 3. So I am writing this like this. Minus 1 2 1 is column, I am writing as row. Then 5 1 3 is column, I am writing as row. Then when I rewrite, so what do I get? I get back the same. So this is when I take the transpose, it is same as A, which is equal to A. So A transpose is same as A. Therefore, A is a symmetric matrix. Symmetric matrix. Fine. Now the second part is, we have to prove that another matrix in the 7th second part. So A matrix is given. So 0 1 0 1 minus 1 minus 1 0 1 1 minus 1 0. We have to show that it is a skew symmetric matrix. We have to show that this A is a skew symmetric matrix. Now how do we show that? So show that, what we have to show? We have to show that A is a skew symmetric matrix. We have to show that A is a skew symmetric matrix, which means, so A is a skew symmetric matrix. So which means we should show that A transpose is equal to minus A. Right? If you show A transpose is equal to minus A, then A becomes skew symmetric matrix. Now let's find what is A transpose. So what is A transpose? Solution is A transpose. A transpose is 0 minus 1 1 1 0 minus 1 minus 1 1 0. So this, if I take minus common, if I take minus common from each element, so 0 1 minus 1, then minus 1 0 1 1 minus 1 0. So which is same as your A, minus A. So this will become minus, and this matrix is nothing but your A matrix. So which is minus A. So we have proved A transpose is equal to minus A. Since A transpose is equal to minus A, right? So we will say A is a skew symmetric matrix. So we write here, so A transpose equal to minus of A. Therefore, A is a skew symmetric matrix. So we have shown that A is a skew symmetric matrix. Fine. Now let's go to the next problem, which is 8th one. It is this. So 8th problem is, so 8th question is, we have to, for the matrix A, so A is the matrix which is 1, 5, 6 and 7. We have to verify that A plus A transpose is a symmetric matrix. So we have to verify that A plus A transpose is a symmetric matrix. And second part that we have to verify is A minus A transpose is a skew symmetric matrix. Skew symmetric matrix. We have to verify this. So solution is, so let's find what is A plus A transpose. Now A plus A transpose is equal to 1, 5, 6, 7. That is my A, plus A transpose is 1, 6, 5, 7. Now if you add them, you get 2, 5 plus 6 is 11, then 11, then 7 plus 7 is 14. 7 plus 7 is 14. Now this is your A plus A transpose. Now if we take that, now we have to show that this is a symmetric matrix. We'll call this as, suppose, B equal to. Yeah, I'm calling this as B equal to. So your B matrix is A plus A transpose. It is this. Now what is the transpose? B transpose. So to show that A plus A transpose is symmetric, which means B is symmetric, we should find B transpose. If B transpose is equal to B, then B becomes symmetric, which means A plus A transpose is symmetric. So B transpose is 2, 11, 11, 14. We try and take the transpose of this, you get this, and which is same as B, which is same as this. So B transpose is equal to B. Therefore B, but what is B? B is A plus A transpose, is a symmetric matrix. It's a symmetric matrix. So we have showed that A plus A transpose is a symmetric matrix. Now similarly, we will have to show that A minus A transpose. Right? Let's try to write what is A minus A transpose. So A minus A transpose, we'll call that as C, second part, which means we are going to prove this second part, right? This part. So we'll call that as C equal to. So C is A minus A transpose. So C is equal to A minus A transpose, and A is 1, 5, 6, 7, and minus A transpose is 1, 6, 5, 7. Now let's subtract them. So 1 minus 1, 0, 5 minus 6 is minus 1, 6 minus 5 is 1, 7 minus 7 is 0. Fine, so this is your C. Now to show that C is a skew symmetric matrix, your C is this, I'm just calling this as C. To show that C is a skew symmetric matrix, we have to find C transpose. What is C transpose? 0, 1, minus 1, 0. Now again, if I take minus common out of this, you'll get 0, minus 1, 1, 0. So that is equal to minus of, and this matrix is what? This matrix is nothing but C matrix. This is matching with this, which is C. So we proved that C transpose equal to minus C. Therefore, C equal to A minus A transpose is a skew symmetric matrix. Skew symmetric matrix. So we have proved that A minus A transpose is a skew symmetric matrix. Fine. So all of you can pause the video and take the notes, and I will stop here. You can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.